Welcome to section 4.3. Get out your interactive notebook and take some notes. The topic of section 4.3 is properties of logarithms. And the overall question is, how can I quickly graph exponential functions, show their critical points, solve equations? What we're doing in this section of the textbook is using these properties of logarithms to rewrite logarithmic expressions. So there are four rules: the product rule, the quotient rule, the power rule, and the change of base rule. The first three rules we use to manipulate expressions to make it easier to do whatever it is we're trying to do. Now, in college algebra, as they were in Algebra 2, these are mainly just going to be an exercise of just practicing using properties, and it doesn't really seem like they have any use. You're practicing them to get ready for calculus. In calculus and in some math classes beyond calculus, being able to manipulate logarithmic expressions to rewrite them in certain ways can make it easier to do some other mathematical things if you remember them and if you're clever about things. So they're a mathematical tool for your toolbox. That's the application. But remember, logarithms do have a lot of applications. So here we go. Get out your notebook. Here are the properties of logarithmic functions, the first three. These properties of logarithms, they're valid for any base, base 10 and base e. So we let b, the base, m, and n be any positive real numbers with the base not equal to 1, and p can be any real number. The product rule is log base b of the product of m and m, so if m times n is equal to log base b of m plus log base b of n. The quotient rule, log base b of m divided by n, so the quotient of m and n, is equal to the difference of their logarithms, log base b of m minus log base b of n. The power rule, log base b of m to the power of p, is equal to p times log base b of m. So these are the first three properties of logarithms, and we use them to rewrite logarithmic expressions. So sometimes we use them when we go this way. So we go from a product, the logarithm of a product, the logarithm of a quotient, or the logarithm of a power. We write it with more terms. That's called expanding. So one thing we'll be doing with the properties of logarithms is expanding logarithmic expressions. Then we'll reverse it. Sometimes we'll want to go from like the sum of two logarithms, the difference of two logarithms, or the product of a number and a logarithm. We'll want to rewrite that as just one term, one logarithmic term, and that's called condensing. Because we're going to be writing it with fewer terms. So we use these properties to either expand expressions or condense expressions. And I'm going to show you some examples of how to expand logarithmic expressions here. So let me go ahead and pin this page, view, pin this page, and boom. So here, example one, we want to expand the following logarithms using these properties. So example A, we've got log of the product of 8 times x times y to the fourth. I want to expand this as far as I can. So I identify what's inside the argument of the logarithmic function. Well, it's a product because stuff is being multiplied together. So I'm going to use the product rule. So remember, identify, state what it is that you have. I've got a product, so I'm going to use the product rule first. So expanding, the log of the product is going to be equal to the sum of the logs of each factor. So log of 8 plus log of the next factor, x, plus log of the next factor, which is y to the fourth. Now, let's look at each term. Log of 8, there's just one factor in the argument. I'm done. Log of x, just one factor in the argument. I'm done there. But here in the third term, log of y to the fourth, I have a power. I can use the power rule to simplify and expand this further. I guess it's not simplifying, it's expanding. So I'm going to keep going. And I'll rewrite the first term because it can't be expanded further. Log of x, the second term, it cannot be expanded further, but this term can be expanded using the power rule. This exponent of 4, it comes out front, so p comes out front, and it becomes 4 times log of y. And that's my final answer. I've expanded that logarithmic expression as far as it can go. Those of you who are taking calculus next year, when you have to take the derivative of a logarithmic function, and there's a bunch of stuff like a bunch of factors or a quotient, this is a really nice strategy for taking derivatives of logarithmic functions. So you got that down the road for you. Next example, we've got the natural log of the quotient of the square root of x squared plus 5 divided by x. So here, inside the argument of the natural log function, I have a quotient. So the first rule I'm going to use is the quotient rule. So the log of a quotient is equal to the difference of the logs, the log of the numerator minus the log of the denominator. So I'm going to go ahead and do that. The log of the square root of x squared plus 5 minus the natural log of x. Now I'm going to look at the argument of each term. The first term, I've got the square root of x squared plus 5. Now that is actually a power when I rewrite that radical using an exponent of 1/2. So there's more work to be done in this first term because I do have an exponent. This is the logarithm of a power, so I'm going to use the power rule to expand this first term. So the first term is going to become, now the exponent, and we just pop it out front, 1/2 times the natural log of x squared plus 5 minus the natural log of x. Now let's see what's inside the argument here of the first term. Well, there are two terms, x squared plus 5, but notice I'm adding them. Is there any addition rule? Well, there's a product rule for multiplication when there's a product inside the argument. There's a quotient rule for when there's a quotient inside the argument. And then there's a power rule for when there's a power inside the argument. But here, inside the parentheses here, inside the argument, I have a sum. And when I have a sum, there is no sum rule. I cannot simplify this further. So I am done. Cannot be simplified further. Cannot be further expanded because it's a sum. I cannot further expand sums and differences that are inside the arguments. There is no rule for that. So here I am done. Here is my final answer, and I will underline or circle my final answer here with a beautiful pen that looks like a rainbow. Here is my final answer right here. This is my final answer. And that's how you expand logarithmic expressions using these properties. So stay tuned for the final question. What questions do you have? After that, make sure you annotate your notes, come up with some questions to bring to class, and we'll get those done.